Okay, here we go. Solving a polynomial function and classifying its roots. If you can do this, then you are all set. You've done everything we've wanted you to do with this chapter, which is just to be able to give you any old polynomial and have you be able to tell us the roots and where it crosses the x-axis. So we're going to do two examples together. If you can do both of these examples with success, you've mastered everything we've wanted you to know in this chapter. So really nicely done. Finding all the zeros of a polynomial function. You can often find all the zeros of a polynomial function by using some combination of graphing: the factor theorem, polynomial division, the remainder theorem, and the quadratic formula. So first, let's list all of our possible roots. So again, remember, we do C, factors of C over factors of A. All right, so factors of C, plus or minus 1, plus or minus 2, all over factors of A, plus or minus 1. So my combinations are going to be positive 1, negative 1, positive 2, or negative 2. So I have four possible rational roots. Okay? So step 2, find a rational root from the possibility of roots using synthetic division to test each root until you get one with a remainder of 0, and if the remainder is 0, it is a root. So we've done this before. This is just a simple explanation for you to see how it goes. So let's test them. We'll put positive 1 over here. Remember, we're using synthetic division. Coefficient of 1, coefficient of 1, coefficient of negative 1, and coefficient of 2. So 1, 1, negative 1, and 2. Let's try it. Drop the 1. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. 2 minus 1, we're adding these together, is 1. 1 times 1 is 1. And 1 plus 2 is 3. So nope, doesn't work. All right, let's try negative 1. So 1, 1, negative 1, 2. Drop the 1. 1 times negative 1 is negative 1. Add those together, get a 0. 0 times negative 1 is 0. Add those together, get negative 1. Negative 1 times negative 1 is positive 1. Add those together, get 3. Doesn't work. Let's try 2. 1, 1, negative 1, and 2. Drop the 1. 2 times 1 is 2. Add them together, get 3. 3 times 2 is 6. Add them together, get 5. 5 times 2 is 10. Add them together, get 12. Boy, I sure hope that negative 2 works, because if it doesn't, we've made a mistake somewhere. Should you just assume? I hope not. You should not just assume. You should definitely check, okay? So let's do that. Drop the 1. 1 times negative 2 is negative 2. Add them together, we get negative 1. Negative 1 times negative 2 is positive 2. Add them together, we get 1. 1 times negative 2 is negative 2. Add them together, we get 0. So we have found a root. Okay? Then it says, if possible, factor the remaining trinomial to find its roots. If not factorable, use the quadratic formula. Okay? So again, I'm starting to run out of space because these markers are kind of big and it's hard to find space. So remember that this is these are the coefficients of our resulting trinomial. So we have x plus 2, because we always do the opposite. And then we have x squared minus x plus 1, whoops, equals 0. So that is our resulting, that's what happened to our polynomial. We factored out a factor of x plus 2, and now we have this trinomial left, x squared minus x plus 1, that we have to factor. So I'm going to just know that when I have x plus 2, right, that I was supposed to set that equal to 0 and subtract to solve, and so I got x equals negative 2. So I know for a fact that that is one real 0, or one rational root. So I'm going to put that there. And now I'm going to see if I can figure out what these two roots will be left. Because remember, I'm supposed to have a total of 3 roots because it's x to the 3rd power. So I found the one root, negative 2. I could have just wrote that right down here at the beginning. I didn't necessarily need to do this stuff. I just want you to make sure that you understand where did that negative 2 come from. And now I'm going to use the quadratic formula. So the opposite of b is 1 plus or minus the square root of b squared. So negative 1 squared minus 4 times a times c all over 2 times a. So that's all coming from here. A is 1, b is negative 1, c is positive 1. So I'm just plugging them into the quadratic formula, okay? And I ask my students to do negative 1 squared, drop it down, and then to do negative 4 times 1 times 1 and drop it down. So I have 1 plus or minus the square root of. Negative 1 times negative 1 is positive 1. Negative 4 times 1 is negative 4. Negative 4 times 1 is negative 4. All over 2. So I get plus 1 plus or minus. Hang on, my marker's sticking. So I get 1 plus or minus the square root of negative 3 over 2. The only thing I can take out from this root is the I. So it says 1 plus or minus I square roots of 3 over 2. And those are my complex roots. Complex because they have both an imaginary unit and a radical in them. So I have found all 3 roots. 1 was real and 2 were irrational. Okay, let's move on to the second example. I'm going to scroll my page up. All right, so let's try it again with this one. List the possible rational roots. So C over A. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Okay, so those are all the roots, or all the factors of 8, and they're all over plus or minus 1. So I'm going to have positive 1, negative 1, positive 2, negative 2, positive 4, negative 4, positive 8, negative 8. Okay, lots of combinations to try. So let's use synthetic division and go right through our list and see what we can find. So I'm going to do it over here. So here's 1, and again, coefficients come right from your equation. 1, negative 2, 4, negative 8. Let's give it a try. Drop the 1. 1 times 1 is 1. Negative 2 plus 1 is negative 1. Negative 1 times 1 is negative 1. 4 plus negative 1 is 3. 3 times 1 is 3, and then this gives me negative 5. So not a root. All right, let's try a negative 1. So again, 1, negative 2, 4, negative 8. Drop down the 1. 1 times negative 1 is negative 1. Negative 2 plus negative 1 is negative 3. Negative 3 times negative 1 is positive 3. Add them together, we get 7. 7 times negative 1 is negative 7, and negative 7 and negative 8 is negative 15, not a root. I will tell you, sign errors in this section are detrimental to you being able to find the correct root. Please take your time. Use a calculator if you absolutely have to check your work. Make sure that you are taking your time, because you could maybe have missed the root on the first one, and then you're testing all 8 and you've gone right by your root, and it's hard to know which one was the one you missed, so then you have to go back to the beginning and try them all over again. So be very careful. Drop the 1. 2 times 1 is 2. Negative 2 plus positive 2 is 0. 0 times 2 is 0. 4 plus 0 is 4. 4 times 2 is 8. 8 plus negative 8 is 0. So we just found a root. So my first root I know is 2. I can go ahead and put it right in the box. Remember what this means though. It means x minus 2, and then I have these coefficients as my trinomial. X squared, I don't have a b term, so I don't need to write plus 0x. I won't write that, but then I will just write plus 4 equals 0. And then what I have to do from here is go ahead and solve. Now normally I would just go ahead and solve, but this one I've already done, right? I already know that it's positive 2, and I already put it in there as my real rational root, okay? This one, the second one though, does not have a b term. I could use the quadratic formula if I wanted to, but whenever you have a coefficient, just one of your terms as a variable, it's easy just to isolate that variable and go ahead and solve. We're going to use the square root property for this one because I only have an x squared term. There's no other term with an x in it, so I'm not going to bother to go through the quadratic formula for this. You certainly could if you wanted to, but when you do not have anything except one term with a variable, it's easy to isolate it. So save yourself some time and use this strategy instead. So we're going to isolate the x squared term, and then we're going to square root both sides of the equation. Okay, so when you square root a perfect square, it cancels and you're left with x because they're inverses. Again, the square root of 4 is 2, and the square root of -1 is I. So this breaks down to plus or minus I, and that should be your two complex zeros, plus or minus 2I. We have 3 roots. It's a cube root function, so we should have 3 roots, sorry. 3 roots, cube root function, or cubic function, I should say. So again, if you can manage to get through these 2 examples and be able to successfully find the roots, you've done everything we've asked you to do for this chapter.